Okay, this is part 3 of the tutorial, and we're going to get into the real purpose of using CAMBAM, generating toolpaths. So the first thing we're going to do is create a new part. Parts are useful for grouping machining operations together. I normally do it by the size of the tool that's going to be used. In this case, we're going to create a part for 1/2-inch end mills and define all the machining operations for that under it. As you see, I got to redefine the stock here. You would think that it would automatically be populated because we defined it up under the machining tab, but it's not. So we're going to redo everything here. And as I talked about in the previous tutorial, you'll see that we have to save everything and then come back in to set the stock surface to -1 again. Alright, now we're going to name the out file. This is where all the G code will be placed for any operation, machining operation that's under this part. You can output G code for each machining operation individually, or if you generate it at the part level, they'll all be put under one code file. So here we're going to define the 1/2-inch end mill. Now you can define more tools in the tool library if you go up into the System tab. But it starts out with some pretty generic ones, and I just use those because that's really all I've used so far. So the first one we're going to do is, see, we have to change the stock surface again. Set that to -1. And there we go. Okay, so the first thing we want to do is generate our profile cut of the body outline. And a profile means you're going to cut around an object, either inside or outside. In this case, we want to cut outside. And I call this one outline rough because we're going to use a roughing operation which will leave a little bit of material on the outside, so then we can do a finish cut. And you can see here the primitive ID, that's the ID of the drawing or polyline that we're going to cut. So we're going to set it, pick a style of cutout with tabs. That means we're going to leave little tabs of material around the cut that will hold our piece in place. So this way we can use clamps to hold down the whole piece of stock and not worry about the cutout shifting as soon as it's cut. So we set the depth increment to 0.25 inches, which is usually you want to cut about half the size of your tool diameter. So in this case, if we cut a quarter inch at a time, the final cut's going to be 0 because our target depth is 1.75 or minus 2.75 on the z-axis. So here we set up what the cut width is, which is 0.5, which is the tool diameter. And then the roughing clearance is the amount of material that we want to leave in the cut. So in this case, we're going to leave about 1/100th, or actually 1/100th. And we choose our tool again, 1/2 inch end mill. And so we've got everything pretty much set up. So the first thing we're going to do is generate our tool path. And you can see that's the green line around the body. And there's our holding tabs. And we can move these to space them wherever we want. Put them down a little bit so there's a little bit more stock left. Now I really want to add one more tab onto this. So you can go into the tab collection and add a new one. Now the one thing you have to add it, you have to remember to set the parent ID number for it to work. So I didn't do it there, and you'll see that no new tab showed up. And if I generate the toolpath, there is nothing there. And usually the new tab will hide under one of the existing ones, but obviously there wasn't one because I forgot to set the parent ID. So go back in the tab collection, click on that last tab, add another one, and go into here and get the parent ID. And set that. And click OK. There it is. And we'll drag it to where we want it. That looks good. And obviously save as we're going along. So now I want to make the finished cut. So what we can do is just copy the rough cut, change the name to outline finish, and then set the properties accordingly. The parent ID stays the same, and we still want the same cutouts because we're going to be cutting in the same place. But we're going to go down and set to finishing. And we'll remove the roughing clearance, set that to 0. And we'll save our file. And generate the toolpath. And really it'll look just like the other one, but it will be incrementally closer. And here you can see how the cutting path actually goes down into the stock. Okay, so we've made our two outline cuts. Now let's set the active layer to the routes layer. And this is, when you set the active layer, that's where you would want to be drawing. So it wasn't really necessary here, but it's a good practice. Because sometimes when you start drawing something and you're in the wrong layer that's active and then you don't see what you're drawing in that layer, that's usually what happens. So here we go. We just hid everything except what's in this layer. And we're going to start out with the control cavity. Now for the control cavity, we're going to do a pocket cut, which means we really want to cut all the material away that's within the object. So we select the control cavity. And we're going to go up and select pocket. We'll rename it to something meaningful. Okay. And you can see it's the primitive ID of the object is 25. The style is, we're just going to leave it blank because it doesn't need cutouts. The clearance plane is 0, which means I set it to retract to the highest point in my machine after cutting or in between operations. So the target depth we're going to set here is 2.5. So the control cavity is going to be 1.5 inches deep. So we're going to cut depth of each pass is 0.25 inch, so the final cut is 0. The cut rate is 100 inches per minute, and the plunge rate is 20. That seems to work pretty well for most of the stuff I've been cutting. Could probably cut pine faster. If it was cutting maple, probably slow it down just a little bit. Those are all things that you kind of have to play around with a CNC machine to try and figure out what works best for you, because there's many factors that influence the cut rate. So we're just going to do a finishing cut here. Select an end mill, the 1/2 inch end mill. Save, and let's generate toolpath. And there you can see it. Control cavity cutout. Okay, now the next thing will be to do another pocket cut, but this time we're going to do the bridge pickup cavity. So we copied the control pickup operation, and we're going to rename it to the bridge pickup. And sometimes it's really hard to type while you're trying to do these kind of tutorials. There we go, Robert. Okay, so the first thing we're going to do is change the primitive ID to the bridge pickup ID. There we go. So the cut depth is going to be all the same, except our target depth is going to be different. So we're going to set it to 8/10 of an inch. And it all depends on your bridge pickup. So we do have to change the final depth increment to 0.05. Everything else is the same. Or since I want to have the same cut each time, I'm going to change the initial each cut depth to 0.2. So the final is 0. So we're going to really have 4 passes around at 0.2 inches. And there we go. Okay, the next thing will be the neck pocket and neck pickup. So once again, we're just going to copy one of the pocket cuts. In this case, we'll copy the bridge and paste it into the part and rename it. And let's see if I can actually type the name correctly this time, but I doubt it. Yep, there's the fat fingers. Okay, so let's see, that's the wire channel, and there's the neck pickup and cavity. Changes to the primitive ID. So the target depth on these, standard is for Tele is 0.625 or inches or 5/8. And we've got that. We produce, oh, a little error there. So there's something in the drawing that probably wasn't closed. So I'm just trying to figure out what I need to do here. Sometimes when you have an object that isn't completely closed, first thing you can do is a join, and that will try and join any open lines on your polyline. You can try clean. There are a few things, and that's will come, I'm sure, with a little bit more use. But there we go. Now we're all set. And let's save our drawing so we don't lose anything that we've done so far. Alright, so let's produce the G-code. And that's it for that. It's going to produce one file that has all these operations in it, and they would be run in order that they're listed under the part. But now I'm going to produce the G-code for each individual MOP or machining operation. Just in case you wanted to run them individually. And I've taken to naming some of these operations starting with a number first, such as 01, 02, 03, so I know what order I should run them in if I'm doing them individually. And I also remove that front part of the name just because it gets annoying to when you try and open the file and you can't read the whole file name. And the other, just one tip, I've been trying to keep all my files for projects together under the same folder so they're easier to find. And you see here I named this file wrong. It had like -3 there, so I'll go back and fix that later. And you can see here I'm thinking, oh, I named one file wrong. So what number am I on now? So we'll just redo this one and change the name, save it as a different file name. Save the overall file again, and we're good to go. So here you can see all the cutouts that we'd be making. So now, let's switch over to Cut Viewer and watch this be run. Cut Viewer is a simulation software for running G-code, and it'll give you an idea of what your part or operations will look like. So I loaded up the file, and here you can see all the G-code that was produced for this one part. And G-code is really just text. And here we go. And I have to tell you, it is a lot more fun to actually watch the machine running and doing this and spitting out sawdust and chips. But this gives you a good idea if it's going to work. It will also give you an indication of about the approximate time it will take to machine your parts. And that's listed at on the bottom of the screen next to machine time. Yeah, you can see one thing here that I noticed is that my cutout tabs were too small. I forgot to size them appropriately when I was defining them. So we'll have to go back into CAMBAM and adjust that. So that's one reason it's a good idea to run a simulation first. And there we are, a finished part. And here, I'll zoom in so you can see these holding tabs and that they were really a little bit too small. Yep. So we'll go back into CAMBAM in the next tutorial and fix those. Okay, that's it for part 3. Sorry it was a little longer. But this was really the meat and potatoes of CAMBAM and what we're trying to do. But there's still more to come. Thanks for watching.